Okay, so let's proceed here for B prime C. B, B, wait, B prime C pala. Wait lang. B prime C. Next is for CD prime. C, D prime. B, C prime, D. The 3 input and gate. So, here, 3 input and gate. So, this is the B, C prime, D. The B, C prime, D. The B prime, D. Okay, so let's connect this one. Wait. Here. Okay, so we need 2 input or gate to connect this as A1 equal C, ID pala. Okay, so next, let's proceed to equation for E. So we need 2 input OR gate, which is 8. Okay, so we need 2 input OR gate. So this one here, 2 input and gate. Here. Okay, so B prime, D prime. Okay, so this one is the B prime. The next one is the D prime. Here. Next, C, D prime. Okay. So the C. This one is the C, then okay. So this is the equation for E. Next, equation for F. So the A C prime D prime plus B C prime plus B D prime. So we need 4 input OR gates. 4 input OR gates. So here the 4072. And the A. So we can directly connect it to A here. C prime D prime. Need this one, this one. Okay, so we need 3 input and gates here. Okay, so D prime, C prime, with wire. C prime, D prime. Next, the C prime, D, C prime, and the BD prime. And I'm going to this one here. Same process, connect here. And Okay, so for the last one, we will going to perform the equation for G. So we need 4072 to 4 input OR gate. So here. So let us have A gate. We will directly connect the A here. Okay, so we will directly connect the A here. Next, the B prime C, C D prime, B C prime. So we need 3 input, the 2 input and gate. So we need to have 3 for that one. Here. 1 and 3. Okay, so the B prime C, B prime and C. For the next, C D prime, C D prime, and for the last one, the B C prime, B C prime. Okay, so we are done performing our 1, 2, 3, 4, 5, 6, 7 equations. So we need to use this one, the 7 segment cathode. Here, I'll put one here. Okay, so let's connect this one. Second. Here, third connect. Also this one. Same process. This one. Here. And the last one. Okay, so we forgot to connect this one. So let's connect. Okay, so we are done making our 4 binary decoder. Okay, so let us delete the this one. Delete wire. Delete wire. And here, delete wire. Okay, so wait. Okay, so we are done making our binary decoder. So next is we will going to create our flip-flop circuit. So we need to use this one. Okay, so because we have 4 inputs, so we will be using also 4 flip-flop. Okay, so wait, here, here, next. Okay, so we're going to make to connect this one here. Okay, so this part we will connect this here. Wait, so same process with same process. Okay, so if by the way, if you're going to run this one, by the way, we forgot to put a ground. Okay, so we need a ground here. Okay, so let us try to run this one. Wait. Okay, so we have here the 1 1 1 1. Okay, so the letter E is off, so we're not going to use the lot right now, because instead of using this one, we will going to use the flip-flop. So in order to have or to have it to display here the 0 to 9 voluntarily. Okay, so instead of using this logic, we will be going to replace this one by the flip-flop. Okay, so let us delete this wait, let us delete this. Wait, let's escape the simulation. Okay, so delete object. Okay, so delete object, so delete, and also here delete. Okay, so let us connect this one. So by the way, this and in this part, this is or A, or B, or C, or D. Okay, so let us connect this to our A. Okay, so to our A here. This is our B. Okay. Or B. Our C. And our D. Okay, so by the way, we need a button here. One button only. So let's go back to the component. So button. Okay. Okay, so we also need for us to operate this one, we need a DC lock. So DC lock to produce a voltage to our in this part. Wait. So DC lock. Okay, so connect this one to our button. Okay. So let us try to run one. And we're going to click the button. So let us see. 2, 3, 4, 5, 6,